Welcome to Spring LIB.
We're given two positive numbers, a and b, and we're asked to find the length of the shortest line segment that is cut off by the first quadrant and passes through the point AB. Well, first of all, the equation of a line that passes through the point AB with a slope of m is y minus b equals m times x minus a. Now, just intuitively, m has to be less than 0. Otherwise, if we had a positive slope, there would not be a line segment cut off by the first quadrant. Now, set x equal to 0, we can find the coordinates of the y-intercept. So we have a y-intercept with coordinates 0, negative am plus b, and an x-intercept. We set y equals 0, and we have that x is equal to negative b over m plus a. This is negative b over m plus a, 0. Therefore, the distance from the y-intercept to the x-intercept, which I'll call d as a function of the slope m, this is the square root of the difference of the x components, which is a minus b over m squared plus b minus am squared. Now, of course, we know that our function d is minimized at the same time when its square is minimized. I'll call this function f. So f as a function of m is a minus b over m squared plus b minus am squared. Now, to find the minimum of f, we'll differentiate and find where this is equal to 0. So f prime of m is 2 times a minus b over m times the derivative of the inside. This is positive b over m squared plus 2 times b minus am times the derivative of the inside, which is negative a. Now, if you simplify, we get 2 over m cubed times abm minus b squared plus a squared m to the fourth minus abm cubed. We set this equal to 0. We can then factor by grouping, so we get 2 over m cubed times, and then we factor a b out of the first and second terms, so we have b times am minus b, and we factor an a m cubed out of the third and fourth terms, and we get a minus b, am minus b again, equals 0, which is going to be factored as 2 over m cubed times b plus am cubed times am minus b equals 0. And with this factorization, well, as we've already pointed out, one possibility is that am minus b equals 0. This would tell us that m equals b over a, which is positive. So this is not the answer. As we already pointed out, the slope needs to be negative. Therefore, the only solution is the other factor, b plus am cubed equals 0. And so m is equal to negative cube root of b over a. Now, in fact, if you think about the way we factored f prime of m, it follows that f prime of m is less than 0 if m is less than negative cube root of b over a, and f prime of m is greater than 0 if m is greater than negative cube root of b over a. Therefore, it follows that f has a minimum at m equals negative cube root of b over a. Now we'll plug this back into our distance function. So we have f of negative cube root of b over a. This is equal to, once you finally simplify it down, there's a lot of steps here I'm skipping, a squared plus 3 a to the 4 thirds times b to the 2 thirds plus 3a to the 2 thirds times b to the 4 thirds plus b squared. So I'm skipping some steps here. But then the length is the square root of this. Now to simplify, notice that we can actually factor this as a to the 2 thirds plus b to the 2 thirds cubed. And therefore, the distance of d of negative cube root of b over a is the square root of this, which is a to the 2 thirds plus b to the 2 thirds to the 3 halves power. And so this is our shortest length.